Hello people and welcome back to another video. In this video, we'll be covering some of the basic rudimentary concepts in R, some basic terminologies, some basic code syntaxes, so that overall we have a foundational base setup as we move along in our journey in R programming. A few caveats before I get into this video. As I mentioned already that this video is going to cover a few basic concepts, some terminologies, and a few coding examples in R, but this is just the beginning. The more we'll progress in these series of lectures, the more we will learn about R programming. So consider this lecture as a starting point, and as we move forward, we will keep adding stuff into our existing knowledge in R programming. Now that that is out of the way, without further delay, let's get into the video. And in the previous video, I've already explained you how to install R and R Studio. And once you have installed both R and R Studio, if you go to your search bar, you type R Studio, and you will find an app like this in your search result. You can click on this and it will open a window similar to this one. Now, before I get into the more finer nitty-gritties, as you can see that this particular R script or R file is untitled. So this is how you create an R file. You go to this drop down, you choose an R script, and you create a new R script. If you click on file in this above toolbar, you have an option to create a new file, and you can create an R script from here as well. Also, this gives you an option to create a new R project altogether. So if I have to save this file, because this file is as of right now untitled, I'll either press Ctrl S or I'll click on this save icon. I'll go to my location and I'll say this file is intro to R. All R files are saved with an extension .r. Now this file has been saved. Also, you can see in this particular window, there are 4 sections in this particular environment. This is the first section, this is the second section, the third section, and the fourth section. Now, what do you see in each of these sections? Let's go over that first. The first section over here, this is where you write your R code. If you want to run multiple lines of R code together, then you write it in this particular frame. So if I have to write, let us suppose A is equal to 1, B is equal to 2, C is equal to A plus B, and print C. And if I have to run this, I'll save, and this is the run button over here. So all these 4 lines of code are going to run together. And finally, because my last line number 4 command is print, it is going to print me the result of C. Now, let me also go over the rest of the frames. So coming to frame number 2, this is nothing but the console. Now, in the console, what you see here is you see the output of the different lines of execution. So this console also works as a platform where we can write our code, but we need to keep in mind that when we are writing our code, console executes only one R command at a time. So let us suppose I'm writing C is equal to C plus 3. It'll execute that. Then I'll write print C. And let me do it once again. If I do print C, then it will show me the result. So console is basically the place where you can see the output of your R code. It is also the place where you can run one line of code at a time and you can check the output. Now, a basic utility of the console is when you have an exorbitantly multiple lines of code and you're getting syntax error, or let us suppose you're not getting the desired result, what you can do in those cases, you can debug your code using the console. You can run one line at a time and you can see what output that line is actually giving. This works as a great platform for debugging. Now, coming to the third window, which is the environment window, here what you see is the variables that get created. If I create any variable, let us suppose I create a variable D and I store the value of 6 here. I create E, I store the value of 7. I create F and I store the value of 8. Whatever variables I create, it gets listed down in the environment section or the third section in the R window. And finally, we have the fourth section, which is the last section. Here, usually in this particular section, we represent plots, figures, shapes, any sort of visual representation that gets represented in this particular section or the fourth section. So now that we have gone over the utility of each of these sections, let us start with some fundamental terminologies which will be very useful as you move forward in your understanding of R programming. Now, as I said, the third environment consists of a list of variables and values assigned to them. So in what essentially a variable is in R is anything that holds a value. Now that value can be anything, which we'll come to later, but if I create a variable, it is very similar to the concept of variables in mathematics. So if you remember in earlier classes, we used to do fundamental linear algebra questions where we used to assign x a certain value, then we used to assign y a certain value, then we need to calculate and do some arithmetic operations on x and y to get the final result z. Similarly, in R, when you create a variable a and you assign it to, let us suppose 1 in this case, then the variable a holds the value 1. And accordingly, if you want to use it in a mathematical operation further down in your code, or if you want to change its value, you can call this variable at a later point in time. Now, as I mentioned already, that variables in R can have multiple types of values assigned to them. So here in this case, you see all the variables A, B, C, D, E, F, they all have numerical values assigned to them. So if you want to look what type of a variable A is, there is a function called typeof. If I do typeof of A, then as you can see that you're getting the result as double. Now, if you are privy to programming, you would know that the length of the double data type is much higher than the length of an integer data type. So to make it more clear, if I have to do A is equal to 8 divided by 2, then A will hold the value of 0.5. Now, let us suppose that instead of my value being a double value, I have an integer value. So here I'll be explaining you two key concepts. First, type conversion, and second, the significance of a data type. So currently, if you look at typeof of B, this is also double. If I have to convert a variable of any data type into integer, then I'll use something called as.integer. Now, if you look at type of B, now you can see it's an integer. Now, what if I do b is equal to b divided by 2? It comes out to be 1. Again, I do b is equal to b divided by 2, or I run this once again. B comes out to be 0.5. So this is a unique feature in R where you're now, if I again run type of B, then B comes out to be double. So another very interesting feature in R is something called as, I don't know exactly what is the technical term for this, but it is also called data type conversion. So whenever there is an operation on a, let us suppose on a data type that is lower in order. Now, what the order of data type is, I'll come to it a little later. But essentially, you need to understand this. If I am performing an operation on a data type which is at a lower level of rank, then the data type gets automatically converted to a data type of higher rank if the operation results in a data type of higher rank. Now, to make you guys understand this in a little more detail, I'll take another example. Now, let us suppose I have an integer and I have D is already, if I go type of C, type of D. So if you look, C is an integer, D is double. Now if I write res as C plus D, now what do you guys think will be the type of res? It is double. So if I do an operation on double and integer, remember the result will always take the data type of the higher order. So the order in R is integer holds the least rank. On top of that comes double. On top of that comes your character. Another example, if I take, let us suppose I take Boolean also in this case. So I have V as true, W as 10, and if I do res as V plus W, then res will be 11. Now here I have added a Boolean with a double, but let me just do W is, because in this case, you know that the result is going to be double because double always has a higher rank than Boolean. Or let me just show it to you just to make sure that I'm right. If I do a type of res, anyways going to get a double. But if I change my value of W to an integer, and if I run this once again, also I'll be telling you what is the type of V. It is logical or Boolean. Now, what is the type of res? See, it comes out to be an integer. So Boolean holds an even lower precedence than integer. So you have Boolean at the lowest, integer on top of that, and double on top of that. Now, let me introduce one more type over here, which is complex. Now, if you have studied mathematics, you must be extremely privy to complex numbers. They have a real part and an imaginary part. So I take another variable called z, 3 plus 2i. 3 is the real part, 2 is the imaginary part. W is an integer, and I just say x. I'll take it as double, which is 5. So let me run all three of these commands. So x is double, z is complex, and w is integer. Now I will add all these three together, x plus w plus z. See, you can automatically see over here that the type of result is complex. Now that we are studying the concept of type conversion in R, let me also introduce you to a fundamental data structure that you will be using very frequently in R. It's called vectors. Now, vectors is basically a series of elements which are of the same type. So essentially, your vector is represented by C, and you can enter n number of elements in this bracket, but all of them must be of the same type. So let us suppose I have a vector v, or let us say I name it vec. I have C of 1, comma 2, comma 3, comma 4. This is a vector with 4 elements. Now, if I do type of vect, it will give me double. And I have already told you that in a vector, all elements must be of the same type. Now, what if I enter elements of different data types? Then a very good feature of R is that it will not give you an error, but it will do type conversion and it will convert all data types to the type of highest precedence. So if I create a vector called vect1, x, w, z, if I have all of these three types, then if you look at this, vect1 is converted into complex because this is the highest type among all the three. Things become even more interesting when I introduce a string. All of these get converted to character. Character is the name of the data type we use in R. It's not technically called strings. It is called a character data type, but character has the highest precedence above all of these. So if I have to mention precedence, and by the way, now that I'm writing it here, this hash is used to give a comment in R. So if you want to make your code neat and understandable to someone who is reading your code, then it's advised that you mention comments in certain sections of your code where you want to make someone understand what your code is doing. So adding comments improves the understandability of your code. So as I was saying, if I have to rank the order of data types from highest to lowest, it will be character, then it will be complex, then it will be double, integer, and boolean. This is the fundamental decreasing order of data types in R. Now we have almost looked at all the major concepts that you would need when you're just starting out in R. We'll be ending our discussion with a very important data structure which is very frequently used in R apart from vectors. It's called data frame. Now, if any of you is coming into these lectures with an a priori experience in any programming language, especially Python, then you know how fundamental and how crucial the utility of data frames are. Now, for those of you who haven't worked previously in data frames, let me just give you a brief introduction. So, usually data frames come into handy when we need to import files or import the data which is present in the files, which are in row and column format, and we want to operate on that data. So I have a sample data set here with me. It's called CEO salary. Now it has three columns: age, height, and salary. Now, if I import this into a data frame, what will end up happening is that each of these three columns will act as three different vectors, and the collection or agglomeration of these vectors will be represented as a data frame. So when I'm importing a CSV file, my command is read.csv. I'll be storing this in a data frame called df. My name of my file is CEO salary. Okay. Now, as you can see on the third frame, df is a data frame of 100 observations, which is the number of rows, and three variables, which is the number of columns. Now, if I do type of on df, it will give me list. There is a head function which can show you the first few rows of a data frame. You have three columns: age, height, and salary. Now, if I want to select only the age column, then I'll be using the dollar operator. Here, once you type dollar, it will show you age, height, and salary. Now, if I want to check the type of df of age, it will come as integer. This is also an integer. So in a data frame, the different columns are stored as vectors, and an agglomeration of vectors is nothing but a data frame. So you can do multiple operations with data frame. As we'll see, the utility of data frames in a plethora of scenarios, situations, and contexts, the more this, the more data frames is going to be clear to you from a coding perspective. But just to give you some basic ideas, if I have to create a new column called, let us say I'm creating a new column called salary one, where I'll be taking salary and I'll be dividing it by 2,500. Now, DF has four observations: age, height, salary, and salary one. Now, you guys must be wondering that salary is a vector. How can I divide a vector with an integer? This is the beauty of R again, that when you mention, when you write a code like this, what happens is, to compensate your length, 2500 gets replicated the number of times as the number of rows you have in this case. So 2500 gets replicated 100 times, and 2500 gets divided in each of the observations which is present in salary. Now you can see that in a different example. Let me suppose I'll take a variable m. This will be a vector, and n, I'll take it as 4. Now if I'm doing m into n, then as you see, what is happening is that 4 is getting replicated multiple times, and each element in m is getting multiplied by 4. Now what if my n was also a vector, 4 comma 5? Now the results will be very interesting. If you look, 4 into 1 is 4, 5 into 2 is 10, 4 into 3 is 12, 5 into 4 is 20. So what is happening is that this vector is getting replicated like this. And if the elements would have been more in M, then it would have kept replicating like this. So you get the fundamental idea that whenever there is a difference in length and there is a mathematical operation, the variable of smaller length gets replicated one by one to cover up that length. So another operation that you can do in a data frame is you can go ahead and select specific columns. So here I'm choosing only the first and second column. Here I'm choosing the first and the second row. Here I am choosing the first, second, and third row and the first and the second column. There's another important concept in both vectors and data frames, which is called slicing. So in slicing, let us suppose I want to choose 1 to 5th row, and I want to only choose my first and second column. See, also what slicing does is that it basically creates a vector from start index to end index. So as you can see, C consists of 1, 2, 3, 4, and 5. So these are some of the fundamental concepts in R. You can take this video as a reference point just to get familiarized with R, but our understanding and our practice of R will not be limited to only these concepts. In the later videos, in our upcoming modules, you will see that we will be adding to our knowledge of R from what we have understood in this video. So please study this video so that your fundamentals are clear, so that in the upcoming modules, when we'll be going over a few advanced concepts, you won't be finding yourself getting stuck at some part because you haven't understood the syntax. So with that, we'll be ending today's session. I want to thank each one of you for watching. I'll see all of you all in the next video.